Hello everyone. We want to welcome you, Grade 10, to our platform, Edge Blush Virtual Academy platform. And we are still looking at electric circuits, right? From the previous presentation that I did, we realized that we have got two types of electric circuits that we are going to look at. We have got what we call a series circuit, and we have got what we call a parallel circuit. So in the previous presentation, I looked at a series circuit, and now I'm going to take this opportunity to take you through what we call a parallel circuit. So the sub title that we have in this presentation is parallel circuit, and this parallel circuit topic or subtopic is under electric circuits, right? So what is a parallel circuit? There are few basic points that we need to always appreciate when we deal with a parallel circuit, and these points will assist us also to go through the rest of the topic, right? Point number one, or should I call it bullet number one? What is it that we need to know when we are dealing with a parallel circuit? Number one, we must appreciate that when we have a parallel circuit, there are more than one path for the current to flow. So in a parallel circuit, there is right, more than one path, more than one path for the current to flow. So in other words, we are saying in a parallel circuit, current divides, right? That's what we are saying. Now, let me just try to take you back a little bit to our previous presentation. This is not the same with series circuit. Remember, in a series circuit, we said there is only one pathway. So current is constant or current is the same. But in a parallel circuit, there is more than one pathway. So in other words, the total current of the circuit divides into different paths depending on how many paths do you have. Bullet number two, or point number two, point to note potential difference across the parallel component is the same. All right, so we need to capture that. The potential difference, right? The potential difference across the parallel. I hope my handwriting is clear. Across the parallel components, is the same, right? So unlike a series circuit, in a series circuit we said uh, potential difference divides, but with a parallel circuit, potential difference is the same. So it's more like the opposite. When you look at current and potential difference between these two types of circuits, in a series circuit, current is constant, but in a parallel circuit, current divides, right? In a series circuit, potential difference divides. In a parallel circuit, potential difference is the same, right? Then another bullet, another point that we need to note there, I've already highlighted that there is more than one path for the current to flow. So in other words, the current divides. So I think I need to take note of that. The current does not just divide haphazardly. The current divides according to the resistance. So current divides right? According to the resistance, So you underline the resistance there of each resistor, or according to the resistance of each pathway, of each path, right? Right. From Ohm's law, it is very important for us to appreciate that current and resistance are inversely proportional. I think I need to capture that relationship. Current is inversely proportional to resistance. This is very, very important. Current and resistance, they are inversely proportional, meaning to say a pathway that has got higher resistance will get lower current. A pathway that has got lower resistance will get higher current because current and resistance are inversely proportional. But still looking at that relationship, we must also know that resistance is the independent variable and current is the dependent variable. So current, the amount of current that flows past through a certain path depends on the resistance of that pathway. So resistance is the independent variable and current is the dependent variable. So current and resistance, they are inversely proportional. We need to take note of that as we are going to be doing our calculation. So if we have got two pathways in a parallel circuit, the pathway that has got more resistance, automatically it means it gets lower current because current favors a path that has got lower resistance. Is that fine? But if the resistance is the same, then it means current is going to divide equally. So this is very important for us to appreciate. Let me just capture another point which I can term NB. So the resistor, should I say the path, okay, the path with the greatest resistance, the path with the greatest resistance will have the smallest current, will have the smallest current. So this is a point that we need to appreciate as learners as we look at a parallel circuit, that the resistance that each pathway has will definitely affect the amount of current that flows through that pathway, right? And remember the last point I made last time, I said when we look at an electric circuit, the total amount of current is constant. We don't lose current along the way. So when we deal with the parallel circuit, it's not like we are losing current. It's just that the total current is going to divide and move into those different pathways, right? But immediately those pathways come together again into the main line. If we add up the total current, it should give us the original total current that we started with, right? But as current divides, I think I need to emphasize and say the path with the greatest resistance will get the smallest current because current favors a path that has got lower resistance. Quickly, let me look at an example of a parallel circuit diagram, and then I do the calculation there and explanations, and then it will be okay for this presentation. At least we will know what is a parallel circuit and how do we determine the total resistance in a parallel circuit. I'm going to look at a parallel circuit which has got only two pathways or two resistors that are in parallel, right? So whenever you draw an electric circuit, remember we said you need a power supply, and we have got a battery there that has got two cells, and it goes that way. And then we have got an ammeter there, and then we have got two pathways here, this pathway with this resistor, and we have got second pathway with another resistor, and then we have got back our, and then our pathway goes that way, right? So the components that I've indicated on this parallel circuit, I've got an ammeter there, I've got a battery, I've got a switch which is closed, meaning to say current can flow now. Then we have got a parallel connection there, those two resistors, which is R1 and R2, they are connected in parallel, right? Should I call this one 4 ohm and this one 2 ohm? And then there is a voltmeter that is connected there, and that is V1. And then I have got my V2 here, right? And then I've got my VP. which is the third voltmeter there. I want you to take note of the way VP is connected, right? It is connected along the conducting wire before current is divided, right? Then I've got the last voltmeter, which is across the power supply, and I call it VT. So this is a parallel circuit. This is an example of a parallel circuit, right? So what is it that we need to know under the parallel circuit? We are simply referring back to the notes that we have already. We are going to look at the three variables, right? Which is potential difference, current, and resistance, right? So I want to start with a current, right? So in this parallel circuit, when current flows, remember we are looking at the conventional current, which we believe flows from the positive to the negative, right? So when current flows via the ammeter there from the positive terminal, when it gets to the point where the two pathways separate, current there is going to divide. But how is it going to divide? The pathway that has got more resistance, the 4 ohm pathway, it is going to get less current. And the 2 ohm pathway, it is going to get more current because current and resistance are inversely proportional, right? So the first point we need to capture, it says current divides, right? Current divides. In my next presentation, I'm going to show you how this current divides. It is also important for us to know how this current divides. We can use different methods. We can even use ratios. Still, it is fine. We can still get the same answer. So current divides here. And how does current divides? In brackets, I should say current is inversely proportional to resistance, meaning to say the pathway that has got higher resistance will get lower current. So in this case, the 2 ohm pathway will get more current as compared to the 4 ohm pathway. So current divides, friends, current divides there. And then the second point, potential difference, right, is the same. Potential difference, as long as we are only dealing with the parallel connection, potential difference is the same. It doesn't divide. So what this means, if we look at the diagram, it means VT will be equals to V1, will be equals to V2, will be equals to VP, like that. That is potential difference. As long as we are dealing with the parallel connection, then what it means is Vt is going to be equals to V1 and is equals to V2 and is equals to Vp, right? Because potential difference is the same. Now, I can't show you how to calculate V1 or V2 calculation now. Before I give you a brief explanation or before I introduce what we call the Ohm's law, because the Ohm's law gives us a formula that we can use, that we can harness, or that we can actually try to apply to our circuits and calculate voltmeter readings or current readings or resistance. Right. So for now at this level, since we don't know the Ohm's law, I'm going to leave it there. But these are the notes that we need to apply in our next presentation. So potential difference is the same. So whenever we are dealing with the parallel circuit, you have got V1 provided, then you must know definitely that V2 will have the same reading as V1 because this is a parallel connection. Then lastly, friends, I'm going to look at resistance, right? Remember with the series circuit, we said resistance increases with increase in number of resistors, which is the opposite of what happens in a parallel what? In a parallel circuit. In a parallel circuit, the total resistance, right, decreases, right, with an increase in resistors, in number of resistors, right? So what it means to us is whenever we add another resistor in parallel, the total resistance decreases. And what effect does it have? Remember, we said whenever resistance decreases, current goes up because current and resistance They are inversely proportional. So in our exam, they might not ask you exactly a straightforward question. Like if we add a resistor in parallel, what happens to the total resistance? No, they won't ask you about resistance. They will ask you about current. If we add another resistor R3 to this a parallel circuit, what will happen to the total current of the circuit? That will be the question that they would be interested in. Now they want to check, does a learner know the relationship between current and resistance? Now the answer to that question would be, whenever we add a resistor in parallel, the total resistance of the circuit decreases. And immediately resistance decreases, current goes up. So in other words, current will go up because current and resistance are inversely proportional, and current favors a path that has got lower resistance. So if the resistance of the circuit is going down, the current also of the circuit must go up because there's now less resistance in the circuit. Now, in a parallel circuit, the last thing that I want us to look at, how do we calculate the total parallel resistance? For example, here we have got two resistors, which is the 4 ohm resistor and the 2 ohm resistor. How do we calculate the total parallel resistance? Now, the formula that we are going to use, allow me to divide the page into two so that we can see the calculation. And so the formula that we are going to use for parallel resistance, it says 1 over Rp is equals to 1 over R1 plus 1 over R2. Is that okay? Now, we can label these resistors the way we want. We can make 4 ohm R1 and 2 ohm R2, or the other way around. But of course, you must follow a sequence or an order that is not going to confuse you as we move forward. So according to me, my 4 ohm resistor is going to be R1 and 2 ohm resistor is going to be R2. So 1 over Rp, I'm making proper substitution there, is going to be 1 over my R1 is 4 plus 1 over my R2 is 2. Right. So I need a calculator there, friends. You can't work, you can't do science without a calculator. So you need a calculator there. Then it's 1, right, over 4 plus 1 over 2. 1 over 2. Definitely you get, which is equals to 3 over 4. But remember, this is 1 over Rp. And we are not looking for 1 over Rp. We are looking for Rp, right? Yeah. So what do we do from there? We reciprocate. And should we say we invert or we reciprocate? And in mathematics, whatever you do to the left-hand side, you also have to do it to the right-hand side. So on my left side, I've got 1 over Rp. So I'm going to reciprocate it, and I will be having Rp over 1. Now, any number divided by 1, it remains itself. So that is going to be my Rp. So Rp over 1 is definitely going to give me Rp. So Rp is going to be, I have also reciprocate on the right hand side. It's 3 over 4, so it becomes 4 over 3. So that is my Rp. Now it's up to you to leave your answer as a fraction or you convert it to decimal. So Rp is also equals to, now if you want to put it in decimal, 4 over 3, 4 divided by 3, you need a calculator and you round it off to 2 decimal place. That is equivalent to 1,33 ohm. That is going to be my parallel resistance. So for now, friends, this is a parallel circuit, and this is how we determine current in a parallel circuit. We must always remember that current divides, but as it divides, it also divides according to the resistance of the pathway. And current and resistance are inversely proportional. More resistance, less current. Less resistance, more current. Then we must also appreciate that potential difference is the same, right? Potential difference is the same in a parallel circuit. So for the purposes of calculation, you must take note of that point. Then the last point, or the last bullet, says resistance decreases with the increase in number of resistors. This one we can prove it. If we can put another resistor, let's say R3, somewhere down there, and we try to calculate our parallel resistance, definitely we must be getting an answer that is lower than 1,33, right? Let me say I put another resistor there, which is 5 ohm, right? I'm not going to write it down. I'm just explaining. You must listen very carefully. Let me say I put another resistor, which is 5 ohm, right? So it means my 1 over RP is going to be, already I've got 3 over 4, right? Which takes note of those two parallel resistors. So I've got 3 over 4, right? Plus, let's say I've got another resistor there, which is a 5 ohm. So it's going to be plus 1 over 5. That is going to give me, let me see here, it's going to give me 19 over 20, right? It's going to give me 19 over 20. Then we reciprocate and 20 divide by 19. I'm getting 1,05, which is less than 1,33. So this explains, or this confirms our point that we have made above, that whenever we add another resistor in parallel, the total resistance decreases and current increases. Now, the last point I wish to explain to you guys is the opposite of this last point is true. When we remove a resistor in parallel, the total resistance increases. And when the total resistance increases, the total current decreases. So please take note of those dynamics so that we won't have a problem with our calculations as we move forward. So thank you so much for watching our Edge Blush Virtual Academy platform. I'm going to present another presentation, and I'm going to introduce a bit on Ohm's law and also deal with a circuit diagram that has got a parallel connection and a series connection, and see how we calculate the total resistance and obviously different voltmeter readings, how we can calculate them. Thank you so much, and we meet in our next presentation. Edge Blush loves you.